You can model 3D mechanical systems by using Simscape multi-body blocks representing bodies, joints, constraints, force elements, and sensors. You can also integrate these models with Simscape networks that represent electrical, mechanical, hydraulic, and other physical systems to build multi-domain systems. As an example, a radial engine where the pressure dynamics inside the cylinders are modeled using the Simscape networks using foundation library gas and mechanical translation domains. Or a bread slicer where the motor is used to actuate the Simscape multi-body joint. Now the question is, how do you integrate Simscape and Simscape multibody? To understand the procedure, let us switch to MATLAB. Here is a model comprising of a basic Simscape multibody where friction and viscous damping are modeled in Simscape. Now to build a connection between the Simscape networks and the prismatic joint, we'll use the translational multibody interface that has been added in the release 21A and can be found in the library browser under the Simscape multibody Simscape mechanical interface. To connect this block to the prismatic joint, under actuation, set force to provided by input to enable the force actuation port F. And similarly, under sensing, select velocity to enable the velocity sensing port V. This will create two additional ports representing force and velocity that can be connected to the interface block. Further, the mechanical translational conserving ports C and R are connected to the C and R ports of the network. Now, you can run the model with the friction and damper effect defined by a physical system. So in the previous case, we used blocks like translational friction and translational damper that do not require position information. And for these blocks, the interface based on the relative velocity is sufficient. However, other blocks like hydraulic actuators require information on relative position or relative angle between their ports. Hence, to incorporate this from release 21A, the converter blocks now have an optional input port that lets you pass position information from a multi-body joint. To implement the same, we'll use the previous multi-body model with a mechanical and liquid network. We will follow the same procedure of enabling the force and velocity port and additionally enable the position sensor port on the joint, and then we'll make the connections. Further, this interface can be utilized in complex examples such as the radial engine where the prismatic joint is moving the piston using gas and mechanical networks. Once you have the interface set, you can leverage the multi-domain model to size the position or any other component, resulting in a more realistic model. So this was the workflow to interface between translational networks and prismatic joints. Similarly, to interface Simscape networks with the Simscape multi-body joints, having rotational primitives, we can use a rotational multi-body interface and follow similar steps to make proper connections. For more information and to learn the best practices, please refer to the documentation dedicated to connecting Simscape networks to the Simscape multi-body joints. Thank you.